I do want to start this video just reiterating how important it is that you are taking notes during the video, that you're not just watching it kind of passively, but that you are an active participant. That just makes it more likely that you're actually going to remember this material later. And this section in particular, there's a nice visual to kind of help us remember certain properties of these trig functions. So taking the time to actually write down this visual might mean you're able to recollect it later, okay? So if you've kind of fallen out of the habit of taking good and diligent notes, try to get back into it starting right now. And if you've been doing it all along, hopefully you've already seen it kind of assist you in the process, okay? Right? You can't be a passive student here, even though this is just an online class. I want you to be active doing your part on the side, okay? So, trig function is still a function. So when we talk functions, we've got inputs, we've got outputs. Okay, so what's my input, what's my output? So here, I'm going to input in an angle, and I am going to output the sides of a right triangle. So a right triangle just means the triangle will have a 90-degree angle in it, okay? So the inputs are angles and the outputs are sides. When I say sides, I don't mean plural, right? Functions can only have, every input has to have exactly one output. It's really going to be a ratio of the sides. So we're going to be seeing some fractions here. So if I start with just a generic right triangle, and I'm labeling the sides A, B, C, C being the hypotenuse, reminiscent of Pythagorean theorem, okay? Then I'm going to have eventually 6 trig functions, but I'm going to highlight the first 3 separately because they're the most important. The sine, okay? Sine is one trig function, but you'll see it abbreviated maybe on a calculator or just in notes or in problems as SIN. Just continue to pronounce it sine with that long I. It's not sin, it's sine. And because this is a function, I have to take the sign of something. So let me come back to my triangle and label one of the angles, because that's going to be my input, Greek letter theta. Okay, so sine of theta. So again, function notation. There's my input. That's the name of the function. What is the output? Okay, something having to do with the sides. So the sine of theta is B over C. Don't really have to memorize that relationship. I want you to think about it in a different way. Think about it as the opposite of theta. So theta is formed by the sides A and C. And what one is not formed by theta is completely opposite. Straight across from theta is B. So opposite over, and we would call side C the hypotenuse of this triangle, right? Opposite the right angle is always called the hypotenuse. So I get this opposite over hypotenuse relationship, and I'm going to develop an acronym. Maybe you already know it. It's fine. Let's pretend your classmates don't, where I take the first letter here, S, the first letter here, O, and the first letter here, H. And I'm going to pronounce this phonetically as so. Okay? Then we have cosine. I'm going to go through this one a little bit quicker. Abbreviated COS. Don't call it cos, just continue to call it cosine. Cosine of theta is A over C. From our picture, we're going to label that the adjacent over the hypotenuse. So when I say adjacent to theta, okay, right, theta is formed by 2 sides. That hypotenuse, I'm not talking about the hypotenuse, and the other side. The other side is the one that is adjacent to theta. Real close to it, okay? So our acronym now is first letter, first letter, first letter, CAH, and I'm going to just call that Ka, okay? And then we have tangent. All right. You'll see it as sort of abbreviated TAN, just continue to pronounce it tangent. The tangent of theta is B over A, which is opposite over adjacent. And our acronym is the T, the O, and the A. So we have so, ka, toa, okay? I just remember it phonetically, but I have heard of other mnemonic devices that other students have told me that their teacher told them. So I'll give you that information if that helps you remember what's going on. So one I have heard is that like some old hippie came around here tripping on acid. Okay, so something like that. Maybe you know one that I don't know anymore, but the point is you need to have some way of remembering. I just remember the phonetics, so katoa, to help you remember the relationship of these three trig functions. Okay, a special note here, it's going to help us build relationships between these trig functions. The sine of theta divided by the cosine of theta. All right, so sine was b over c, cosine a over c. So again, fractions within fractions. Let me take a moment and multiply by the reciprocal. C's cancel, and I end up with the result that's b over a. But b over a is tangent. So I have this nice relationship that sine divided by cosine is tangent, and that's going to be useful when we do computations in the future. What that means is these two trig functions are the most important. If I know these two, I can get to tangent just by doing some division and not having to do lots of additional work. All right, I did briefly mention we would have 6 trig functions. There's only 3 up there right now. We got 3 more coming. All right, so there's cosecant, which you'll see abbreviated just CSC. It is the reciprocal of sine. I don't know if you caught that right there, but I almost forgot to write the theta. Don't forget to do that, okay, right? This cosecant is a function, okay? So I need to have an input to that function. When we talk about functions, I don't just write f equals x plus 5. I write f of x, okay? So I need to have some sort of an input there. Don't lose your thetas. So it's the reciprocal of sine, so it's just going to flip that fraction, c over b, okay? Cosine has its own reciprocal called secant, abbreviated SEC. So the secant of theta is, flip that fraction, c over a, and then we have cotangent, which is going to be the reciprocal of tangent. So flip that fraction, you'll have a over b, okay? So I don't have a nice mnemonic for this one. If you know it, that's okay. Maybe post it to the discussion so that way everyone has a good way of remembering it. But I will tell you how I kind of remember it because there's a lot of like weird terms here that you don't use every day. Sine, his reciprocal is the one that starts with the C, okay, right? So we see like it starts with S paired with starts with C. Same thing here. It starts with C. The reciprocal, I forgot to write what the reciprocal was, 1 over cosine. That could be helpful. His reciprocal is secant. So again, the S is paired with the C, and these have the same root word in them, so they're associated as reciprocals. Okay? So having all of those at the ready will be important. All right, I mentioned at the beginning of the video how we would have some visuals. That's more than just that one triangle that was there. We have, in fact, 2 very special triangles that we are going to develop these trig functions for, okay? So one triangle is called the 30, 60, 90 triangle. These are the degree measures of that triangle, okay? So I'm just going to do a rough sketch, right? We're not in protractor land here. There's my right angle. 30 degrees should be the angle opposite the small side, and 60 degrees should be the angle opposite the large side. So I've got like a small side and a large side. Try to draw it that way so you have that emphasis, okay? I'm going to figure out what's going on in this triangle. If the hypotenuse is 1, okay? I'm forcing this to be the case. It doesn't have to be the case, but I'm forcing it to be the case right now, okay? So suppose I actually had 2 copies of this triangle, one on the left, one on the right. Well, the hypotenuse would still be 1. And this angle here would be a 30 on the left and a 30 on the right. So total all the way across would give me 60. And because this is an exact copy, down here in the bottom right is also 60. So if I add those, I have the 60, 60, 60. I have an equilateral triangle. That means this whole base is 1 unit. And that means just the base of the initial triangle with all the dotting is half of that. Okay, so what I am doing is developing from scratch the sides of this triangle, given that the hypotenuse was 1, okay? Now I am missing a side. I am missing this height, okay? But I can get it with Pythagorean theorem. comes up all the time. Pythagorean theorem tells me the squares of the sides summed together. I don't know this one. I'm going to call it b. And then for Pythagorean theorem, I'll have plus b squared is equal to the hypotenuse squared. And now I have one unknown and I can solve for b. So b squared equals 1/4 plus b squared is 1. Square the numerator, square the denominator. We just did properties of exponents. Hopefully you remember some of those. Subtract 1 minus 1/4 is 3/4, and we get that b is square root of 3 over 2. I'm taking the square root of the top and the square root of the bottom. Square root of 3 does not simplify, square root of 4 does simplify. So I'm going to replace that over here. So I have this triangle, and I know all of its side measures. If I know all the side measures, I can figure out the sine, the cosine, the tangent, and anything else I could possibly be asked. The other triangle is the 45, 45, 90 triangle. Let me see if any of these other markers will start showing up a little better. Okay, 45, 45, 90. This is called an isosceles triangle. 2 of the angles are the same, so I need 2 of the sides to be the same roughly. Okay, so maybe I make one side just a little bit bigger for emphasis there. Okay, so I've got a 45-degree angle, a 45-degree angle, and a 90-degree angle. Same as before, I'm forcing the hypotenuse to be 1. If you know why, it's because we're doing unit circle in a few days, so that's going to come up real soon. I don't know these, but if it's an isosceles triangle, 2 angles are the same, 2 sides are the same as well. So instead of needing an A and a B side, I just have A sides. And I can still use Pythagorean theorem. A squared plus A squared equals 1 squared. How do I simplify these? This is an A squared, this is an A squared. I got 2 of them. All right, I'm not doing anything fancy with the exponents. These are like terms, adding them together. Divide both sides by 2. Take the square root of both sides. Square root of 1 is 1. Square root of 2 does not simplify. That's not normally how I will be writing it though. I'm actually going to go a step further and get the square root out of the denominator, rationalizing this function. If I multiply the top and the bottom by the same thing, I'll still have equality. But by doing that, a square root times itself is like saying a square root squared. Squares undo square roots, so my denominator is just 2. The numerator, 1 times root 2, is root 2. Okay, so now I know all the sides of this triangle. Okay, so what I'm going to do is I'm going to erase all that work, and here's why. I don't need to redo this work again, okay? What I'm going to do instead is just use this work to be able to answer questions about any of these angles. Okay, so what that means for you is you're not going to be required to recreate. Oh, I lost my height here. You're not going to need to recreate the work behind this triangle as long as you can remember the triangle, okay? If you're not good at memorizing, you can reconstruct it using some Pythagorean theorem computations, okay? But if you do just remember it, then you won't have to reconstruct it. So it's your call. Are you good at memorizing? Do you prefer not to? You know, maybe at first it's not memorized, and then you can just refer to these in your notes. So what I'm going to do is I'm going to look at, okay, what are some of these angles? And right now they're all measured in degrees, but sometimes I'll need to talk radians. And in fact, mostly from here on out, I should be forcing myself into radians. Radians are way more useful. All right, then I'm going to calculate the sine of that angle, the cosine of that angle. So I'm just building a table here that I'm going to fill in later, and I'm going to do the tangent as well. Okay, I'm not going to do the other 3 because the other 3 are just going to be the reciprocal. There's cosecant reciprocal. This is going to be secant reciprocal. This will be cotangent reciprocal. So reciprocal just means I would flip the fraction. I'm not going to record all of that. All right, so the special angles, 30, 60. Not going to do 90 degrees today, okay? We'll attack that one probably next video. 45. Those are the 3 I'm going to focus on. All right. here's where you sort of have a self-assessment, okay? Can you convert these to radians? Pause the video, look back at previous videos notes. How did we go from degrees to radians? Can you do that right now? Okay. If you can, okay, here's our process. I'm sorry, if you're struggling, I'll help you with one of them. 30 degrees, I need to get degrees to cancel. Okay, so I'm going to multiply by 1, but a very clever one. 180 degrees is the same thing as pi radians. So these are the same number. So if I multiply and divide by the same thing, I'm really multiplying by 1, and I still have equality. The degrees cancel, and I'll have radians. 3 goes into 18 6 times. The zeros are going to cancel. So I'll have pi over 6. Okay, now that you've seen one, you can pause the video if you didn't already and do the other two. I'm going to record them here, believing that you have done this work as a test for yourself, right? Ungraded, just to check in, make sure you're doing okay. So sine, all right, so remembering that sine is the so part of SOHCAHTOA. So from 30 degrees, I need opposite over hypotenuse. 1/2 over 1. Dividing by 1 doesn't change a number. Any number divided by 1, right? If I have 5 whole things and I divide them by 1 part, I still have 5 whole things. Right, 5 cookies, and you give them to one friend. That friend gets 5 cookies, okay? Continue with 30 degrees. Cosine, what is adjacent? Okay, well, not the 1, that's the hypotenuse, but adjacent is the root 3 over 2. Again, dividing by 1, dividing by the hypotenuse. If I use the part of SOHCAHTOA, doesn't change, it's root 3 over 2. Tangent, TOA, opposite over adjacent. So 1/2 over root 3 over 2. Let me do that scrap work. I don't like to divide fractions. We multiply by reciprocal. Hopefully things cancel. The 2's cancel, and end up with a result that's 1 over root 3. Okay? If you want to rationalize that denominator, you can. I'm going to choose not to. WebAssign's not going to force you to either. I won't force you to on a test. That's acceptable. All right, I think we can move a little quicker through 60 degrees. Sine, opposite over hypotenuse, root 3 over 2. Cosine of 60 degrees, adjacent over hypotenuse, 1/2. Tangent, opposite over hypotenuse. The 2's are going to cancel the same way they did over there when you multiply by the reciprocal, just root 3. All right, pi over 4, or 45 degrees. Doesn't matter which one I look at. The opposite over the hypotenuse is going to give me the same answer, root 2 over 2. The adjacent over the hypotenuse also gives me the same answer. And the tangent, when I do opposite over adjacent, any number divided by itself, is 1, okay? So again, these are the visuals you need to have in your notes, so you kind of have this idea of where these numbers are coming from, and then this main result down here, especially the relationship between radians and the trig functions, is going to become increasingly important through the next few lessons, okay? Make sure you've got this so you can refer back to it. If you already knew this coming in, that's great, okay? That just means you had a good trig background. If not, that's okay. These are the resources you're going to use.